R3 Operation Performance Design of the Freight Car Air Brake System. Introductory section present with a discussion of the operation of the performance of the problem of the freight car braking system as they exist today with the material covered under each of these topics. Summarized below. Operation section presents with the detailed function of the description of the brake system, the component of the braking the brake system, design of the train brake operation. Performance section discuss the regulatory requirements applicable to the brake system, describe their impact of the train brake performance. Problem of the section delineates problems associated with the air brake system from the standpoint of the yard processing. Train handling also include the recommendation concern for the trainmen or the training of the enginemen. 3.2 Operation. For the purpose of the section for the describe the operation for the air brake system, the term of the freight train handle, the first of the functional description of the air brake system, the requirements of the presented, first kind of the brake rating are discussed, followed by the brief discussion of the air brake system design of the train brake operation. Brake system components, most common freight brake car brake system component of the arrangement. Even the freight cars today is shown figure 3.1. Show the typical arrangement of freight car brake system components. And the freight car shown in Figure 31 is above the typical four-wheel truck boxcar equipped with the AB type of the brake arrangement, the pneumatic segment, the compromise of the AB operation, control valve combined with auxiliary and emergency reservoir with the brake zone with the pressure retaining valve, all of which were permanently mounted to the car body. The mechanical or segment of the compromise of the brake cylinder, lever for the slack adjust the brake rod, the truck lever the brake beam with the brake head, the brake shoe. Handbrake is also permanently mounted to the car body with connection with the live cylinder, lever by means of the chain, the bell crank with the connection rod. The 1 1/4 inch of the dynamic brake pipe extended from the end to end of each of the car, connecting the hoof of the angle cap mounted with the end of each of the car. Is through the pipe of the compressed for the air travel of the locomotive to each of the car through the respective freight car control valve of the charge of the auxiliary emergency reservoir. Approximately 6,000 cubic inches of the compressed air are stored in the two reservoirs each of the car with the braking energy. Figure 3.2 illustrate the typical piping arrangement found with the freight cars today. Show the angle air hose, angle cock, dirt collector, 1 inch pipe, cutout cock, ABT type control valve, 3/4 inch piping through the two compartment reservoirs, pressure retaining valve with the A1 reduction valve, the 1 1/4 inch pipe, the 3/4 inch pipe, the brake cylinder, 1 1/4 inch pipe, 1 1/2 inch pipe. Typical AB air braking arrangement, Air Brake Association 1972, used for the brake permission by the copyright owner. Figure 3.2 show the 1 1/4 inch brake pipe extending for the two ends of the end of the car from the T, 10 branches for the brake pipe of the air for the T, connection pad for the 1 inch brake pipe with the branch pipe with the real bowl type of the dirt collector through the cutout cock, the end of the brake pipe bracket with the which for the control valve is mounted with the air continuing to flow through a microfilter, typical of the pipe grab with the impact through the surface portion of the control valve, recharging the charging with the two air reservoir of the pipe with extending with the air pipe bracket with the reservoir brake cylinders of 3/4 inch of the diameter, while pipe of the retainer of the valve with 1/2 inch of the diameter. All the diameters, pipe length, and bend radii must conform with the insulation requirements approved by the Association of American Railroads. The A1 reduction relay valve shown with the constant currently required with the freight cars have the total length of the brake pipe of 65 feet. On purpose, the purpose of the valve is assist with the control valve of the propagating surface with emergency rates for the brake pipe reduction. Pressure retaining valve with the G of the railroads where the descending gravity condition required with the partial brake applicable while the car reservoir of the being recharged. Pressure retaining valve is also shown in Figure 3.2. Currently mandatory on all freight cars offered with the interchange with the retaining valve handle on down position. Air of the brake cylinder is directed to the atmosphere following with the release of the train of the brakes without restriction. Moderation retaining valve has 3 positions, namely release, high pressure, and slow direct position. The valve is placed with the high pressure, with the portion of the pressure of 200 psi retained with the brake cylinder when the pressure is released. The provided minimum brake constant brake applicated for the train when descending the steep grade. The retaining valve is placed with the slow direct position. Brake cylinder pressure is completely exhausted, and when the brake is released but at a slow rate, retainer of the valve must be manually operated with an individual. Each of the car must be properly positioned before it's descending with the grade manually repositioned to release position at the bottom of the grade. The brake cylinder shown in Figure 3.2 has an inside diameter of 10 inches of the length of the 12 inch of the cylinder must be installed on the car so that the 8 inch piston travel the wheel. Position the live cylinder lever at 90-degree angle with the 90-degree angle is most efficient for the position of the transferring with the mechanical force. It is important to know that 8 inch of the piston travel is necessary to retain the proper volume of the relationship between the air reservoir with the brake cylinder during all degree of the brake application. The pressure developments within the cylinder with respect to the train brake pipe reductions are discussed below. The plan AB control valve was first introduced to the railroad industry in 1921, adapted and standard with the 1933, still acceptable interchange surface. It should also be noted that because of the material of the car shortage during Second World War, the older D type of the triple valves was not excluded from the interchange surface until about 1950. ABD type of the control valve was introduced in 1962, was granted unlimited approval of the interchange surface with 1966, and it was adopted the steering valve with all new freight cars in 1974. The principal operating change was introduced for the ABD valve, the wear of the brake cylinder relief, the feature of the tube, the accelerated release feature, also the result of many of the coordinating tests examination conducted with the ABD control valve apparently Had operated satisfactory relationship or reliability to receive the 10-year cleaning period or CONTNS versus the 4-year cleaning period not required now required with the AB valve, which endeavor improve the slack control with the reduce the top distance during the surface braking with the new feature of the known with the continuous quick surface will be incorporated as well as an integral part of the new ABGW valve introduced to the rail freight industry with the 1974. The valve is presently being evaluated with the AAR performance and reliability date. It's not how it been granted AAR unlimited approval of the interchange service. Figure 3.3 below the schematic view of the ABGW of the valve. This feature of the control valve will be discussed later in this section, and it shows the ABGW valve with integrated continuous quick service. 322 brake system rigging. The brake rigging provided with the mechanics transfer. They apply with the pneumatic force for the produce of the brakes on the wheel of the freight car with the figure 3-4 below show the 3 different brake rigging arrangements. Direct acting release conventional rigging of the top rod over the bolster, and the conventional rigging of the bottom under the bolster. 3 types of the brake rigging arrangement. Figure 3-4 as in the direct acting type of the braking with the employee with the one cylinder, each of the brake ring with a hand brake with the functional only one trouble. They have no selected drum for the control and piston trouble the necessary for the brake shoe thickness for the next seam with 1/4 inch for the make of initial with the installation for the necessary for the prevent except for the piston for travel after the brake shoe have become worn. It's probably with the design to maintain the proper volume of the relationship between the air reservoir and the brake cylinder. View B with the figure 3-4 show the conventional rigging with the having the one brake cylinder with the connection rod with the 2 leverage range with the top rod that is over the truck bolster. View C with the figure 3-4 similar to the top 2B except that is designs of the connection rods are located under the truck bolster. Both B and C show the conventional rigging within the handbrake function over the both trucks. Figure 3-5 compared with the force diagrams of the conventional direct acting brake of the rigging arrangements. Direct acting brake assembly. Top rod over bolster, solid bottom type car. Bottom rod under bolster, center sill, less covered hopper car. Brake rigging force diagrams bottom view. WAPCO 1974 used the permission of the copyright owner. Comparison of the made with the figure 3-5 between the force for the distribution and direct acting of the conventional rigging with the between the top rod over the bottom rod under types of the conventional rigging. Direct acting conventional rigging arrangements exhibit the difference in efficiency, loss of the lever ratio efficiency. Losses occur within the brake cylinder themselves with each of the pivot point with the pin in connection with the rigging and shown with the figure 3-5. The direct acting rigging has 4 brake cylinders as compared to the 1 brake cylinder with the conventional rigging. With this procedure, large brake cylinder with the efficiency loss of the direct action type of the rigging, however, the conventional rigging has considerably more rigging pivotal pin connections than the direct acting rigging. As a result of the direct acting rigging is generally considered to have lower net efficiency loss. The overall leverage ratio that can be reduced for the direct acting rigging without multiplying leverage is less than that which could be reduced with the conventional rigging. The theoretical lever ratio is 12-5, 12.5 to 1, with considered the maximal for the conventional rigging of the direction action of the rigging unless the double action cylinders has a lever ratio equal to 2 to 1. 323. The brake system is designed with the brake system for the freight car must include the many consideration. For example, depending on the type of the car, the ventral rigging may not be possible. The alternative to be covered the lack of the shape of the association of the rods of 11 to 10 cars without center shills. However, the primary consideration of the brake system is designed so that the determination of the proper level of the brake force that should be applied to a particular car with the wind both loaded and empty. Determination of braking force of the various modes of the braking with the permanent and paramount concern with the most wheel, the rail, adhesion, limited wheel thermal capacity, and relay with the importance of these two specific criteria. The AR has the top of the performance specification which must be applied with the designing brake of the system of the new freight cars to determine the design level of the brake shoe force of the lightweight with the gross rail load of the car must be known. Also, preferred type of the brake shoe with the high friction composition, low friction metal must be specified with the demands for the using information for the brake system designed to produce the net brake shoe with the force specified with the AR inner term of the empty load car wheels. The value of the brake shoe force is then divided by the car weight is known by the net brake ratio. Prior to the adoption of the AR net brake ratio as design parameter, the theoretical braking ratio was used referred to simply with the braking ratio. But the theoretical braking ratio could be calculated using the engineering equations as follows. Braking ratio is the total theoretical brake shoe force car weight. Brake ratio can be calculated based on 50 psi brake cylinder pressure. Brake pressure of the panel panel over W, which is brake cylinder pressure, but the brake cylinder area, number of the cylinders, lever ratio over the car weight in pounds. Thus, the brake ratio of the theoretical and the simple efficiency level of the brake cylinder brake rig was not considered in this calculation. Cover the many variations of the brake system design and the more exact calculation of the design level of the net brake shoe force was neither the design parameter, but is now known as the brake network. The net brake ratio is currently used defined as follows: net brake ratio is equal to the brake cylinder pressure for the brake cylinder area of the number of cylinders, and the Braking efficiency and lever ratio over car weight, calculated by 50 psi prime, based on 50 psi brake cylinder pressure. Thus, the brake braking efficiency they include with the calculation of the net braking ratio, as mentioned above. The AO requires all new cars to meet with the specified net brake ratio, both loading and empty, but depending upon the type of the brakes you've selected. The AO net brake ratio specifications are as follows: cast iron low friction ratio with 15%, coefficient fraction with 60%, 60 miles an hour with 50 psi brake cylinder pressure at net brake ratio, gross load 13% of the limited low weight 53%, high friction composite brake shoes 33, coefficient friction at 60 miles per hour, 50 psi brake cylinder pressure, network brake ratio, gross load 6.5, light load 30%, net braking ratio, actual produced under the static conditions that are sampled with the new cars according to the FRA requirements. Train air brake operators. The section discuss how the train air brake system responds to the various control inputs of the performed locomotive engine beginning with the charging system of the locomotive, the air valve through the connection brake pipe with the hose between the car, each of the car and the train. On a particular car with the air passes through the branch pipe with the cutout cock with the bolt direction with the cut electric through the microfilter onto the face with the bolt to serve as emergency position pistons of the brake control valve with both the pistons over the force downward into the release and charging position. The auxiliary and emergency reservoirs are charged to the controlled rate with the governed by charging choke with the interpretive portion of the control valve with the controlled rate of the charging is necessary to alleviate the heavy drop in the brake pipe pressure at any point with the train, and also to keep the pressure with the high and possible uniform propagation of the release throughout the train through the emergency portion of the brake pipe air charges the quick action chamber to locate with the pipe bracket of the control valve assembly. 3241 brake surface application to apply the brakes for the engine man measure the amount of the brake pipe reduction with the observer the high his air gauge the normal train handling of the minimum brake pipe reduction is usually 6 psi. Therefore, assuming the brake pipe pressure will produce the locomotive with the 70 to 64 psi, the exhaust of the brake pipe air pressure will commence with the locomotive to continue until the pressure reaches 64 psi with the head end of the train. When the brake pipe reduction is felt along the outer surface of the piston of the control valve with the car with the pressure beneath the piston, move the piston upward, causing the graduation valve with the moving the valve with the slab of the valve with the movement of the graduating valve permanent with the measure of the amount of the brake pipe of the air, the flow with the quick surface of the volume, control volume of the exhaust activity of the control of the valve serves in the aid of production brake pipe pressure for the throughout the train during the application to assist propagation of the application throughout the train. The sequence of brake pipe auxiliary reservoir airflow through the system limiting valve through the brake cylinder to apply with the brakes. Limiting of the valve presents the brake pipe air pressure to enter for the brake cylinder after the brake cylinder pressure reaches with the limiting valve setting, which approximately is 10 psi. This is feature is called the preliminary quick service. Additional service range reductions may be made by the engine man by further reduction brake pipe pressure on the locomotive. However, the pressure within the auxiliary reservoir and the brake cylinders become equalized. The maximum brake cylinder pressure is reached. The equalization of the auxiliary reservoir and the brake cylinder pressure is known as a full service application. Alright, it should be noted that the cars equipped with either of the AB and ABD valves, all reduction of the air for the brake with the pipe must be vent through the control of the orifice within the locomotive automatic brake valve. That's required for the substantial amount of the time to make the complete brake application on long freight train. This is the reason that cars with the brake pipe length with the 65 feet or longer are not required to have an A1 reduction valve. Now required to have an A1 reduction valve and 12 of the brake pipe to assist with the propagation and serve the application for the purpose of these features is to provide continuous quick service locally venting brake pipe air during all stages of brake pipe reductions. ABDW control valve incorporates the feature for the integral part of the control valve. The emergency portion on the left of the pipe bracket of the C figure 3.3 serves no real purpose during the service application. However, the brake pipe pressure does change on the top of the emergency piston, prevent the piston from moving to the emergency position. It is necessary that the quick action chamber air vent from under the piston during the service reductions. This air is vented to the atmosphere at the bottom of the emergency portion of the control valve. With the brake pipes and reduction, the air pressure builds up in the brake cylinder as follows. Assuming the initial brake pipe pressure is at 70 psi, the most pressure that could be built up into the brake cylinder would be approximately 50 psi. This is due to the volume relationship between the auxiliary reservoir and the 10-inch brake cylinder based on the piston travel to 8 inches, ratio about 2.5 to 1. For example, the brake pipe pressure reduced to 10 psi to 60 psi. The volume of the air released from the auxiliary reservoir would reduce approximately 25 psi of the brake cylinder. If the brake pipe pressure were reduced to 50 psi with at 20 psi reduction, auxiliary reservoir pressure would be 50 psi of the pressure from the brake cylinder would be 2.5 times greater with the reduction of the 50 psi. This would consider a full service application because the auxiliary reservoir brake cylinder pressure have been equalized Additional brake pipes pressure for the reduction at service rate. Pressure lower than 50 psi would not affect the change in the auxiliary brake and cylinder pressure. As mentioned before, the brake pipe running from the locomotive to the rear of the train is only the communication from the locomotive brake valve to the brake valves on the car. The single pipe that is used to discharge of the system make all reductions and relief of the brakes on the train. 3242 brake relief. The relief of the train brake, the engine man placed with the automatic brake valve of the locomotive in release position, allowing the brake pipe pressure to be restored to its governing setting, called the feed valve on the present locomotive. When brake pipe pressure is increased about 1 3 quarters of the psi higher than the auxiliary reservoir pressure, the service piston of the car control valve move the release position, thus allowing the emergency reservoir air to flow through the brake pipe to assist in accelerating the relief. The feature is found with the ABD type valve with the not in plane with the AB valve. Both AB and ABD valve permit emergency reservoir airflow to the into auxiliary reservoir to assistance in charging. While the service piston of the release position slide valve opens to permit the brake with the cylinder air to exhaust by the way of the retainer valve. Alright, 3243 of the brake emergency application. The emergency application is made with reducing brake pipe pressure for the rate of the significantly faster than surface rate. Thus, emergency piston moves the extreme position, permits quick action chamber to air to flow with the face vent of piston, forcing the vent valve to open in position. This allows the local venting of the brake pipe air fast rate, thus sustaining the propagation of the brake pipe reduction at a rate faster than the surface rate throughout the train. During emergency application of the emergency reservoir air combined with the auxiliary pressure to provide higher pressure of the brake cylinder. During the emergency, the buildup of the pressure of the brake cylinder is ultimately 20% higher than the full surface application. Again, it should be mentioned that an A1 valve on the cars of the brake pipe length with 65 feet or longer operates separately from the AB type valve with the venting brake pipe air during an emergency and serves as an aid of the propagation of the emergency rate. Alright, 3.3 performance requirements. The AB type control valves have been designed to meet the performance specification for the freight brakes adopted in the AR in 1933, revised in 1947. Some of the important requirements are as follows. General requirement: the design of the operation valve should be such that it will ensure efficient, reliable operation both in the application of the release function and with intermingled with the other type of the power brakes. Should be constructed to the rate of the brake cylinder pressure of the development. They may be adjusted to meet the such change with the train operation conditions as they develop in the future. The design of the surface of the emergency valves shall be permitted their removal of the cleaning repair without disturbing the pipe joints. The proportion of the car brake with the control of the brake of the application relief, the also brake cylinder shall be adequately protected against the entrance of foreign material. The apparatus conforming to the requirements of these specifications shall be constructed and installed and maintained to be able to stay suitable in the service. 2 surface requirements of the apparatus shall be designed and constructed to serve the base for 70 pounds brake pipe pressure train length with 150 cars with surface reduction of 5 pounds. Equalizing reservoir with the brake valve. All of the brake pipes will apply. Initial equalizing reservoir reduction of the brake valve will produce a substantial 10 pounds pressure in the brake cylinder. Over the first and 150th brakes will be nominal in the 20 seconds or less. Brake pipe reduction of 10 pounds will be resulting in a pressure in each brake cylinder of not less than 15 pounds, no more than 25 pounds. Total brake pipe reduction of 25 pounds will result in an equalization of brake cylinder pressure with the pressure in the reservoir from the compressed air and is supplied with the brake of the cylinder. The brake cylinder pressure is not less than 48 pounds, no more than 52 pounds will be obtained. Quick service activity of the train brakes will cease due to the initial quick service action has been completed. Quick action feature for the brake will produce the substantial uniform type of the quick service transmission regardless of the unavoidable variation in the friction resistance of these parts. The brake will be so functional to prevent the degree of the wave action of the brake pipe pressurization to cause an undesired release of any brake while the brakes are being applied. The degree of stability of the sufficient to prevent the undesirable surface application occurring with the result of the unavoided minor fluctuation in the brake pipe pressure. The brake cylinder pressure increase with the resulting from the quick surface operation will be less for the brakes applied with the pressure can retain the cylinder, but then with the application made within the brake cylinder pressure at 0. Undesired quick action will not result with any rate of the change of the brake pipe pressure which may occur during the surface application of the release of the brakes. In normal relief of the train brakes, an individual car brake will not start the recharging until the brake pipe pressure has been increased sufficiently to have been accomplished for the release of their adjacent valves. The recharge auxiliary reservoir is in the forward portion of the train will be automatically retarded while full release position of the brake the train will be automatically retarded while the full release position of the brake valve is being used in the initiate the release of the train brakes. After 15 pounds of the production has been made with the brake valve exhaust, the scope of the release operation in which the brake valve is moved with the release position. After 15 seconds, them is moved with the running position, and all operation valves will move with the release position within 40 seconds after the brake valve is released in the release position. The rate of release for the pressure for the brake cylinder will normally be 23 seconds from the 50 pounds to 5 pounds. Alright, emergency requirements of the apparatus shall be designed and constructed at the base for the 70 pound with the brake pipe pressure for the train length with 150 cars for the emergency application the operation will allow always be available irrespective of the existing stage of the stage of the brake application and the release. Emergency application initiated during the release of the previous brake application will reduce the material and increase the brake cylinder pressure of the wedge for the result from the simple server the application made under these same conditions. Alright, emergency requirements. When operating valve acts for the emergency, it will function as developed a nominal 15 pounds brake cylinder pressure in not more than 1.5 seconds, maximum pressure in nominal 10 seconds. With an emergency reduction of the brake pipe pressure, all brakes, including the 150th, will start to apply within 8.2 seconds. Develop not less than 15%, no more than 20%, except for the 50-pound brake cylinder's pressure within 18.2 seconds. Moving the brake valve to the emergency position. Alright, the operation of the valve will so function that when the emergency application is made subsequent to the surface application that is produced with not less than 30 pounds of the brake cylinder pressure for the maximum brake cylinder pressure will be obtained the nominal 4 seconds with the beginning of the emergency application action of the valve. Emergency application from the charge system will produce between 15 to 20% of the increased brake cylinder pressure over which the result of the whole surface application respectively any of the degree of the prior surface application. With any of the group of the 3 consecutive brakes cut out, an emergency reduction made of the brake valve will cause the remainder of the brakes to operate in emergency and produce the nominal emergency pressure within the same time as well if all the brakes are cut in. Brakes will so function to accomplish the release of the emergency application with the same degree of the certain security of the release for the surface application. When the release brake valve with the emergency application, each of the brake will function as the degree of the auxiliary reservoir pressure prior to the actual release pressure. Full surface emergency brake application will be released when the brake pipe pressure is increased not more than 1/3 of a pound above that of the auxiliary reservoir. And respectively increase in frictional resistance to relief of the movement of the piston slide valve though after the period of the operation and the train service. Alright, 332 discussion proceeding requirements of the air brake system component of the performance implied actual brake system performance. I have discussed the following surface requirements of the presented above as the air surface requirements can briefly summarize with a brake pipe pressure of 70 psi for a 150 car train. 1. A 5 psi reduction of surface rate must propagate through the train and cause all brakes to apply. The 5 psi reduction must produce at least 10 psi brake pressure, cylinder pressure on each car throughout the train. One of the primary implications of the requirement, if shown in the graphic in figure 3.6 below, shows the time in seconds over the train length of the cars. As shown in figure 3.6, the head of the car brakes typically start with a function less than 4 seconds. The brakes of the 150th car do not start to function until 16 seconds later from the time of the engine man brakes. Make the reduction to apply with the brakes. Should be noted that figure 3.6 shows the brake pipe pressure signal propagation through the train. The actual brake cylinder pressure build up of the given car begins at the time shown. Figure 3.7 illustrates the brake pipe pressure reduction and the brake cylinder pressure build up propagation at the time of the typical 150 car train. Pressure PSI train length car 150 cars. It shows the brake cylinder in the car was 1 through 50, time in seconds. As shown in figure 3.7, the brake cylinder with 150 car does not reach the 10 psi with 30 seconds of the time when the engineer had made the application. The distance for the heavy tonnage of the freight train would travel before the speed would travel to produce the following 5 or 6 psi. Brake pipe reduction can be discernible. Therefore, in less time, the distance are favorable with the engine man may start with the second reduction before the brakes actually apply with the rear portion of the train. This could move the slack toward the head and end of the train, causing the violent slack action forces. Figure 3 illustrates how the ABW valve is continuing with a quick surface accelerated application feature intended to apply with the brakes to the rear portion of the train more rapidly than the current AB and ABD type valves, or the illustration of the ABW valve appear with improved toward alleviating slack action under certain conditions toward reducing train stop distances. Again, it should be noted that the ABDW valve has only recently been granted limited approval for testing and interchange services. Alright, show the pressures, ABDW performance, comparison of the ABD full-time surface reduction application times. As shown in Figure 3A, the ABDW produces a substantial reduction in time delay for the full surface production compared with the ABDW 3322 release performance. The AR performance specification for the air brake release rate is partially summarized as follows. The rate of the release pressure from the brake cylinder will nominally be 23 seconds from 50 psi to 5 psi. The rate of release for the pressure from the brake cylinder must uniformly alleviate slack action, assuming that their release rate of each of the cars match fairly well, that there is still a problem with the communication of the release signal to each of the car at the same time. This is shown in Figure 3.9. Alright, shown in Figure 3.9 with the 40th car starts with relief within 10 seconds, found with a 25 psi brake pipe reduction. The 150 car with the AB brake valve regulate requires a 25-second longer for the ABD with accelerated release feature for the equip of the car. This 100% improvement over the communication rate with the head of the car to the 150th car. 3-4 problems. Alright, the preceding section will describe the operation of the performance requirement of the air brake system. This section will delineate with the discover the problems associated with the freight train air brake system used today. You are processing virtually all classification of the brake system. Air must be bled manually from the reservoir of the brake cylinder. Expedite with the handling of the cars after classification. When a train air is being assembled, all air hoses must be coupled manually. Each of the angle cock must be checked to see that it is properly positioned for air to move through the brake of the pipe. The other routine items include the examination of each of the car, determine that each of the brake is cut in, and if the brake shoes are and replaced as needed, the handbrakes or retainer valves are released. After the above inspection is performed, the train air of the brake system must be charged with the compressed air using either locomotive consists of the yard plant air. As shown in Figure 310, the charging time typical range of between 35 to 45 minutes required much longer time if their air brake pipe system leakage throughout the train. Train system charging time versus train length. When the brake pipe pressure at least 60 psi or no more less than 15 psi, the difference for the head end of the rear of the end of the pressure, rear end pressure of the established for the rear of the train. The standard brake test of it must be made to determine the brake pipe leakage is not in excess of the 5 psi per minute. Piston travel does not accept the brake with the shoe with the contact of the wheels properly with braking is not binding and other conditions are satisfied. After the brake test has been satisfied, the train is ready to depart with the initial terminal. No additional brake tests are required within the limit of 500 miles on the left of the train. If that has been changed, unless the interchange rules or other special instructions that have been made must be specified by an individual carrier must be enforced. Air leakage can create problems in charging trains, causing the undesirable emergency application of undesired release of the train brakes. If intermittent limited with the amount of the braking engine energy stored in the car reservoir toward the rear of the train. Figure 311 shows how the air leakage concentrated in the rear of the portion of the train can affect the brake pipe gradient. Eventually concentrated in the rear brake pipe test. 60 to 80, 0 to 50 to 150 car numbers. Alright, to compensate with the leak of the top of the road with the remote air of the outraging system along train when operating low ambient temperature, the system typically consists of the repeater unit car with the air compressor with the respond with the two the relief the signal with the train brake pipe. This also accomplishes the same purpose with the remotely controlled locomotive units placed in the rear portion of the train. The approximately effects of the system are shown graphically in Figure 312. Or the top figure of 312 shows the train with the locomotive supplying air for the head end with the temperature of the 0 degree Fahrenheit and the train length must be reduced to about 100 cars or left. The middle curve shows the use of the repeater relay used to increase the brake pipe pressure. This method shows the train length to be increased approximately 50% of the repeater unit. Finally, the bottom curve shows that the radio control locomotive unit can boost the brake pipe pressure enough to permit more than 100% of the increase of the train length compared with the average train. Although these methods have been proven beneficial with the train length, it's important to care of these problems and supervising the use of these methods of the problems include knowing that where to play for the units in the training, making the proper brake tests, and the finally switching of the unit of the in and out of the train, getting into the to and from the point of use. Alright, 342 over the road problems. Over the road problems resulting in the air brake system include the train delay, the train derailment, the damaging rolling equipment associated with the cost of the image of the content of the addition of the cost of the suitable investments made with the training, with the engine and management of the training, overall type of the train. A few of the principal problems associated with the moving fast, manifest, or slow tonnage trains are light reduction, desired heavy reduction, required air hose failure, partial undesired surface release, undesired emergency application, uneven brake force throughout the train. Route training with the engine man is essential, particularly with the main must lay out with the railroad to respect the grade of the curve of the signal location, meeting the point, speed restriction, track conditions, special move associated with a specific portion within the railroad. When knowing the railroad in these terms will benefit the engine man during the adverse weather condition, likewise enable to do the exercise good judgment and the use of the pulling and or returning power. Knowing the character of the route enables the engine man to cope with some of the unexpected and some of the braking variables over which it has no control. Some of the unexpected variables must be coped with during overall the road operation summarized above. The faster the train is operated, the more significant the problems become. Uneven brake force throughout the train representing one of the most difficult problems for the engine man to cope with. A single train make of the braking character of the very consideration able considerably from day to day. The problem of the uneven train braking forces can be discussed in referring page figure 313. Alright, show the elevation, the unusual case sag or dip in the distance. Symbolic representation train being operated undulating train. Figure 313 conserve the operation of the mixed train, with considering the empty cars weighing between 25 and 30 tons, fully loaded cars with the gross railroad loads with 100 tons or more. The engine man must be aware of the train length with the character of the various draft, the gear of the design, to exercise good judgment and adjust pulling power with the time braking response. If the train is moving over the train, requiring slack to be held with as much of the possible light brake pipe reduction, 6 psi more desirable, with a reference to previous discussion of the brake application response time of the pressure that may be necessary to wait 30 seconds before attempting to make another reduction, depending on the speed of the wave of the train with a large distance that may be traveled before the partial application of the brake shoes have been affected. The speed of the train very appreciably often the second heavy reduction is made too soon, causing slack to roll and harshly resulting in in-train shock. In above example, perhaps a light reduction of 6 psi would slow the train down smoothly, particularly if they were a long train, but there may be a risk of having brakes to take from such light reductions, so they're thinking of the possibility of braking sticky. The engine man may have the heavier reduction than needed now, unless with extremely good judgment in the use of the power and timing of the release made. Both heavy run in and run out of slack may be experienced. There are unavoidable circumstances where the engine man have no control, such as the burst of air hose of the train separation. The problems could be acute if the train is lengthy operation, the moderately fast speed. Worse if it's moving over the undulating terrain with emergency brake application resulting from the large upper opening and the brake pipe could cover the slacks to move the variable controllable therefore would be ideal. But in this case, for the every car with the control equal to acceleration rate, regardless of the loss of the grade, gross rail load. Any deviation from this rate can cause the slack to move in any direction. However, therefore, the view of the train makes consistently equal braking force throughout the train. There have also been many other circumstances where the time will not permit the engine man properly to program the locomotive power reduction with the selection brake pipe reduction in order to adjust the train slack. Emphasis must be placed on the train man and engine man to enable to fully understand all ramifications involved with the train handling. Education programs should cover the simulations of all facets of the train handling, including all models of the locomotive to familiarize the trainee with the various locomotive control and stand arrangements. First-hand information should be provided with the describe of the behavior of the various freight car brake arrangement. The brakes response to information concerning the various car types should include the long coupler arrangement and cushion type for draft gear with the more movable center sills. Thus, information should be described and cover the high lateral force of the well as draft and buff action. More thought should be exercised in improving and developing methods for the engine man to breathe, air consumption, brake power, throttle power, buff and draft forces, all of these which can be used for the planning of the use of the power and brakes. Chapter 4, Railroad and Private Car Owner Survey.